This is question 11 from the Cambridge International Exams, June 2020. It's paper 1-1. In the description below, you'll find a link to an image of this question. I recommend you trying it before watching my solutions. I've done my best to draw the picture they gave us, but it looks a bit wonky. Basically, what we have is a line here. They gave us the equation of that line, 2y plus x equals 8. And they have a curve, or at least part of a curve. And that equation of that is y is equal to 8 divided by x plus 2. And the question they ask us, first of all, is find by calculation the coordinates A, B, and C. Now C is, C is the point that would be a tangent. Sorry, C is the point where the tangent of this curve is parallel to this line. That makes sense. Basically, the slope of, if I were to draw a curve in here, the slope of this is equal to the slope of this line. And A and B are just the intersection points. So let's do these separately. Let's do A and B first, because they're the intersection between these line and a curve. Now, the easiest way to do is to rewrite the line. Instead of 2y plus x, let's write 2y is equal 8 minus x. Y is equal to 4 minus x over 2. Actually, you know, I would hate to leave it this way, so I'll leave it as minus a half x plus 4. I much rather writing my lines this way. I have the x first, because there's the slope, which we're going to use later. And here's the intercept. Actually, that already tells me this. If it does in fact intercept the x-axis, the y-axis, I already have this point here. But I guess maybe it's an optical illusion. Maybe it's really close to it and not quite there. So we better do more of the sums. Okay, and the curve is y is equal to 8 over x plus 2. Now that I've got these y's, I can just put them equal to each other. Or more to the point, I put the other sides equal. So I get minus a half x plus 4 must equal 8 over x plus 2. And let's multiply both sides by this. So basically this appears here and appears up here. I wish I hadn't marked it off now. X plus 2. Right, let's multiply this in. We get minus a half x squared. How many x's do I get? I get 4x here, and I get minus 1x here. So I get 3x. And then let's see, what numbers do I get? 2 times 4. I get 8. All that equals 8. Well, the 8s cancel. And we're left with minus a half x squared plus 3x equals 0. Let's take an x out of everything. X comes out this guy, we're left with, let's write 3, well no, I'll leave it the way it was, minus a half x plus 3 equals 0. So this is just factorized for us already. So x could equal 0, that's one possible answer, x equals 0. Or the other answer is this equals 0. So, well, let me do that out quickly. X plus 3 equals 0. So x is equal minus 3 divided by, multiplied, I guess, by minus 2. So x is equal to 6. There's our two answers. Remember, that's not a point. That just gives us the x number. It was, in fact, 0. So we better put the y number in. X is 0. Let's see, here's y equals. Either of these will do. Yeah, either will do. I'll use this one here. X is 0, so 8 divided by 2. Y is 4. I already knew that. That's what that number told me. And this guy here, y is equal, let's see, 6. 6 plus 2 is 8. 8 divided by 8 is 1. There's our two coordinates. Let's see, A is equal to 0, 4. That one was A, yes. And B is equal to, there it is there, 6, 1. All right, so that's A and B. For part C, it's not too difficult, but we do need to differentiate. Let me see, I'll rub this out here and we'll fit it all here. So we have to differentiate this curve here. That's because it'll give us the slope of a tangent, and we're interested in the tangent here. The slope of this tangent, in fact, we already know it. It's the same as the slope of this, which was minus a half. Let's write that here somewhere to remind ourselves. Equals minus a half. And so let's try to differentiate this guy. Y is equal, before I try to differentiate, I'm going to rewrite it. 8x plus 2 to the power of minus 1. You don't have to do this, by the way. It's just, I find this is the easiest way to differentiate things. And dividing is just the same as to the power of minus 1. So it just makes differentiation a bit easier, in my opinion, because it allows me to use the chain rule. Nobody likes using the quotient rule. And the chain rule, though, is much easier. 8 gets left alone, it's just constant. And let's see, we differentiate this guy here. Let's pretend this is how I do the chain rule. I pretend what's in the bracket is just an x. So x to the power of minus 1. How do we differentiate? Minus 1 comes down. We write x again, or in this case, the bracket. And we take one number away from this. So that comes minus 2. And then we differentiate what we just ignored. So what was in the bracket, we now need to differentiate. The derivative of that is 1. You don't have to write that in, just to make it clear that I'm using it. So this is equal to minus 8 divided by x plus 2 squared. That's the derivative. And we know that's equal to minus a half, because it's the same slope as this guy. I'm just double checking it is minus a half. That's minus divided by 2 is a half. So we just need to answer this. Let's multiply around here. We get let's have minus 2 on the bottom, multiply it across. So we get 16 is equal x plus 2 squared. I got a bit ambitious on how much I can fit here, so let me make a little bit of room here. So what squared will make 16? Well, it must be plus or minus 4. So plus or minus 4 is equal to x plus 2. Or think of it, get a square root of both sides out. Being careful with at least one plus or minus there. And so we rearrange this. X is equal to minus 2. Take 2 away from both sides, and I'm flipping it. Be careful, I'm going a little fast. You can pause the video, don't slow me down. X is equal to minus 2 plus or minus 4. So that means x must equal minus 6 or x is equal to plus 2. There are two answers, although we can throw one away already. It's not minus 6. This guy here is not at minus 6. He must be at 2. Minus 6 is all the way over to the left. This curve looks something like sorry, not like that, like this. So there is one answer here and another answer a good bit to the left. But they gave us a picture, so we know to ignore this one. We know x equals 2 now. If x equals 2, y must equal, let's see, 8 divided by 4. Y must equal 2. So 2 is the point C we are looking for. Okay, so that's part A. That's a long question. 6 marks for it, so you get a lot of marks. Difficult question. Part B is going to be difficult as well. Let me clear some room and we'll get into that. Okay, part B is a difficult question, I would say, but students actually do quite well in it because it comes up every 1 or 2 years and you can learn off sort of how to do it. We're going to rotate this shaded shape through the x-axis. I'm going to make this weird looking shape out of it. Now we can do that in 2 parts. We rotate the line around first. We'd make some, if you can visualize, you don't have to, we'd make some sort of cone with the nose cut off when we cut that around. And then when we get this shape here, it's going to be more like a spire or something with a curved edge, a cone with a curved edge. And we're going to cut that out of the middle of it. You don't need to know any of that. You just have to get used to how to do it. So we're going to do 2 parts, like I said. We're going to rotate AB, the straight line first, and then we're going to rotate AB, the curve. Now, let me write this guy again here. Y is equal to minus a half x and, let's see, plus 4. It's going to be much more useful to use that way. So how do we do this? We use integration. Integration cuts it in. Actually, no, I don't need to explain the whole thing to you. I think you can do a different class on that. Well, I'll end up explaining a lot of it, I think. The volume here for this first part is going to be equal to pi. Think pi r squared. It's going to be loads of disks. Loads of disks. This one disk, another smaller one, another smaller one. So that's why we use pi r squared. Or is this height here basically. Or is going to be this height here. So y. Or is going to be y. And we're going to add up loads of them. So we use integration. So it's minus a half x plus 4. That's the y part. But it's pi r squared is a circle. And then for a disk, we multiply by the height. And in the case, the height here is this little small gap. We'll call that dx. That's where all that comes from. And most students, I would say, don't understand it well, but they can do it. So I guess that's half the battle. I would rather they understood it though. Okay, so how do we do this? It's a tough question on its own. We first have to square it out. It's too hard to integrate. Oh, one last thing. We're integrating between 0 and this number, which I think was 6. Yeah, I can't see the answer. I'm just going to go with my gut and say it was 6. Down the bottom of the screen, if there's a correction, might be appearing now. So let's do this. Let's go pi. I won't put 0 and 6 in every time. Save myself some time. Let's square this out. We would get x squared over 4. And 4 times a half is minus 2. 2 of those we get minus 4x. 4 times 4 is 16 dx. So now we're integrating that. I guess it's not too much work for me to put 0, 6 in. We're integrating that. That is equal to pi x to the power of 3 over 12 minus x squared minus 2x squared. 4 divided by 2 is 2, and we get plus 16. Let's put in a bracket here, and we're going to evaluate that between 0 and 6. So basically we've just put 6 in for all the x's, and then we put then we get that number and take away when we put 0 in for all the x's. And I have the answer wrote here somewhere for me. The answer comes out to 42, and don't forget the pi, 42 pi. Now that was just the straight line. I would say that was the easy part. Let's do it again. I won't, let's say volume 1. And volume 2 is equal to pi integrated between 0 and 6 again. This time it's going to be 8 divided by x plus 2 all squared. Actually, let's just make this a little easier on ourselves. Say 64. We'll do them separately. 8 squared is 64, and the bottom row squared. And then the x. Now that's a difficult question to do. Some people can do this in their head. Well done. If you have trouble with that, I do, to be honest. I just substitute. The hard bit here is the x plus 2. X plus 2. If I had a u there instead, I know how to integrate just something that's u squared on the bottom row, or u to the power of minus 2. So I'll do this, but if I'm substituting, I need to know what du dx is. That's equal to 1. That's good. It tells me du is equal to dx. Now I can go ahead and replace a lot of things here. v2, instead of this, is now equal to pi. 64 didn't change. U is on the bottom now, and instead of dx we have du. That's a much easier question to do. You can change the numbers here. They won't be 0 and 6 anymore. They'll be minus 2 and, let me put that in, minus 2 and 4. You're not actually going to need that in this question, so you might have questions about this. Ask them in the comments. I can certainly answer them. So let's integrate this guy. This is the same as u to the minus 2. Same, easier for me to look at it this way. So the integral of this is pi 64 u to the minus 1 all divided by minus 1 between between two numbers. We'll put x back in a moment. That's equal to pi 64 minus 64 over u. Well, that's also equal, that's evaluated somewhere, That's also equal to minus 64 pi over, instead of u, we had x plus 2. And we just need to evaluate that between 0 and 6 again. I've changed back to x's, so I'll change my numbers back to 0 and 6. Or you could have done it with these numbers. 0 and 6 is easier though. And I think it'll be easier for you guys to understand. Okay, so when you put 6 in here, take away, when you put 0 in, you'll get numbers for both of them, but when you take them away, you will get 24 equals 24 pi. So that's the volume under the curve. Volume under the line minus the volume under the curve will give us the volume from this shape here. So that is 42 pi minus 24 pi is equal to, let me not mess this up, 18 pi. So that's the volume of this. I can't draw it. I would say you could use it as a cup if you're able to visualize that. It would turn into a shape like this from the side, but inside would have sort of this. We're looking through the cup at this point. Would look like this here. So let's fill that in. Fill that in. So it would fill liquid in there if you wanted it. There is the bottom. Here's the bottom here, and it's been rotated around. Oh, so the bottom actually hits like this. I apologize. Let me clean some of that up. It's sort of like a that. It would make an interesting cup. Probably stop you from spilling as well when it's at the bottom. All right, if you have any questions about any of that, I went fairly fast on some of that because it's a long question. If you do have follow-up questions, put them in the comments and I'll be happy to spend more time on it. Okay, thank you and have a good day.